All right, welcome in everyone. I am your host, and today I'm stepping into the role of your head coach. We are running a masterclass film review right now, and we're breaking down the absolute most complex defensive strategies of the Cambridge Mathematics 9709 examination. Specifically, we're pulling up the tape for 3.1 algebra. We're talking about the binomial expansion of 1 plus x to the power of n, specifically for rational n. Okay, let's dive right into this. Look, if you're prepping for this exam, you already know the syllabus is incredibly dense. But what we're doing today isn't just, reading through a textbook of formulas. No way. We're going to look at the exact academic benchmarks you need for logical, structured reasoning. We're basically going to analyze the principal examiner reports like it's championship game tape. We need to figure out exactly how the exam board sets up their defense, and more importantly, exactly how you can execute a flawless offensive drive to secure every single available mark. So grab your notebook, get laser focused, and let's get into the film.
15%. You might be wondering why this massive number is up on the board. Well, did you know that this single topic, 3.1 algebra, the binomial expansion for rational n, accounts for roughly 15% of the total marks in your Mathematics 9709 exam? That is a massive chunk of your final grade sitting in just one specific zone of the field. You literally cannot afford to fumble here. This isn't one of those topics you can just kind of skim over the night before. It requires absolute mastery of the underlying math. The examiners are specifically targeting distinct cognitive domains here. They want your basic knowledge, sure, but primarily they are testing your application and analysis of expanding expressions with fractional and negative exponents. They want to see if you can handle complex algebraic manipulation without completely dropping your terms. Look, 15%? That's the difference between scraping by with a passing grade and absolutely dominating the league table.
So, the crucial question we have to ask is this: are you leaving easy points on the field? Because honestly, every single day, students walk out of that exam hall thinking they completely nailed the binomial expansion, only to find out on results day that they dropped crucial marks. Why does this happen? Because they don't really understand the grading rubrics. The assessment framework isn't just about getting the final coefficient right. It rests on precise definitions, establishing causal relationships, and proving to the examiner that you actually understand the underlying concepts, like the constraints of a rational exponent. For instance, knowing that the expansion of 1 plus x to the power of n for rational n is only valid when the modulus of x is strictly less than 1. If you're just out there memorizing the formula and plugging in numbers without verifying that validity condition first, you are essentially fumbling the ball at the 1-yard line. You've got to know the rules of the expansion and leave absolutely nothing to chance.
Let's look at the tape of two classic candidate archetypes we see popping up all the time in the examiner reports. We'll call our two players Alex and Sam. Let's break down their plays. So Alex plays a heavy defense. Alex is honestly great at writing out every single tiny factorial step, but totally lacks open-ended speed. When the question asks for a justified recommendation or an evaluation of validity bounds, which, remember, are higher-order assessment objectives, Alex just gets bogged down structurally and runs out of time to state the final range of x. Then we have Sam. Sam is a fast attacker. Sam rushes straight to the final calculation, but is just incredibly sloppy on the execution. Sam forgets to put brackets around negative terms, like negative 3x, which, as you know, completely destroys the signs of the final coefficients. According to the examiners, candidates exactly like Sam lose marks constantly for these unforced algebraic errors. Both of these players have baseline knowledge, right? But neither is securing full marks. We need to build a playbook that combines Alex's structural precision with Sam's speed.
And this right here brilliantly illustrates the exact tactical play you need to run to secure what the examiners call method marks. Examiners absolutely love giving marks for the process. If you follow this standardized sequence, you lock in those method marks even if your final arithmetic goes a little bit off track later on. Step 1, deconstruct. Ask yourself, are you dealing with a positive integer or a rational fraction, like negative 1/2? This dictates your entire formula. When n is a rational fraction, the series goes on infinitely, meaning you have to use the specific progression, 1 plus nx plus n times n minus 1 over 2 factorial times x squared, and so on. Step 2, solve systematically. You have to execute your analysis with clear, unmistakable working, keeping all those tricky signs and powers in careful brackets. Step 3, evaluate. Check for reasonableness and explicitly state your boundary constraints. It's a strict 3-step route, and you have got to run it perfectly every single time.
Now, this brings us to an advanced strategy straight from the principal examiner reports. I'm reading directly from the playbook here. Candidates referencing cross-topic connections achieve significantly higher marks. So what does this actually mean for 3.1 algebra? It means the binomial expansion doesn't just exist in a vacuum. You might be handed an algebraic fraction requiring you to decompose it into partial fractions first. That results in terms like a over 1 plus x plus b over 1 minus 2x squared. Only then do you bring those terms to the numerator with negative exponents, making it 1 plus x to the power of negative 1, and then you run the binomial play. Showing the examiner that you fully understand how this rational expansion relates to partial fractions or even complex integration, that proves your analytical depth. It shows you aren't just running a rote memorized play, you've actually read the defense and you understand the entire game board.
All right, blow the whistle. Time out. We are exactly halfway through the film review, and I need you all to make a crucial halftime adjustment right now. If you want to stay at the top of the league table this exam season, you have to be consistently reviewing your tactics. So, I need you to hit the pause button on your brain for just 1 second, subscribe to our channel, Ace the Exams at the handle @AceTheExams, and make sure you enable all notifications. You definitely don't want to miss a single masterclass because we are breaking down the tape for every major topic on this syllabus to ensure you are 100% exam ready. All right, water break is officially over. Let's get back onto the turf and look at some of the most critical mathematical errors you have got to avoid.
Welcome back. Let's look closely at the defensive traps. I have completely combed through the past principal examiner reports, and I've pulled out the top 3 tactical mistakes candidates repeatedly make under pressure. Number 1. Confusing cause and effect. Examiners report that students fundamentally mix up the logical progression of their expansion. They often confuse the initial terms of their series by completely failing to factor out constants to get the bracket into that strict 1 plus x format. Number 2. Forgetting format and presentation. The syllabus demands strict conventions, folks. We're talking proper headings and crystal clear annotation of your x cubed versus your x squared terms. Number 3. Answers are not specific to the context given. If the question gives you a boundary condition, like the modulus of x is less than 1, and you just ignore that specific context in your final answer, you are going to be penalized heavily. These are totally unforced errors, team. We have to clean them up.
I am flashing the red lights here for a major examiner alert. Terminology. The precise use of academic mathematical vocabulary is a professional skill you absolutely must develop. The principal examiner reports explicitly state that candidates consistently confuse key terminology regarding validity. You must clearly define your terms. If you're explaining why a certain expansion is valid, you need to use the correct terminology for a convergent series and state your validity bounds explicitly, like actually explaining that for the series to converge, the absolute value of the x term must be strictly less than 1. Superficial explanations without real mathematical justification will literally get you 0 marks for the evaluation section. Listen to me, the examiners are actively looking to deduct points if your understanding of these boundary definitions is weak.
All right, cleats in the grass, it is time for our interactive drill workshop. We're going to build some serious mathematical muscle memory right now. Get ready. This is Drill 1, the 60-second rapid extraction. In the actual exam, when you are hit with a complex algebraic expression for a binomial expansion, you do not have time to sit back and ponder. I want you to imagine a giant timer counting down from 60. Your objective is to deconstruct the expression immediately. Is n a fraction, like -3/2? Is there a coefficient hiding in front of the x, like a -2? Do you need to factor out a constant first to create that essential 1 plus x format? The mental clock is ticking. You need to extract that data and set up your foundational equation before you even write the full sequence down. The absolute fastest, highest-scoring candidates process the complex text, isolate the key mathematical variables, and set up the board instantly.
Now, once you've rapidly extracted the data, you execute this 5-step sequence. Step 1, identify those key elements, which we quite literally just drilled. Step 2, apply relevant principles. This means clearly stating the exact binomial formula for rational n that you are about to use. Step 3, execute the analysis with clear working. This is where you actually crunch the negative fractions and powers step by step, making absolutely sure you don't drop any negative signs inside your brackets. Step 4, verify results. Take a second to check for reasonableness. Did your alternating signs follow the correct pattern based on the negative power? Step 5, present in format. Ensure your final polynomial answer groups all like terms correctly from ascending powers of x. If you practice this exact 5-step drill every single time you tackle a past paper question, your hands will just run the play automatically on game day.
Okay, time for Drill 2, Spot the Penalty. I want you to imagine you're looking at a student's answer sheet. Let's say it's our fast-attacking player Sam from earlier. Look at Sam's expansion of 1 minus 2x to the power of a half. Look really closely at the calculation for the x squared term. Do you see it? Where is the penalty flag being thrown? Well, he correctly wrote a half times negative a half times negative 2x in parentheses squared, but he completely forgot to divide the whole term by 2 factorial? Boom! Flag on the play. That is a massive technical error that completely throws off the final coefficient. You have got to train your eye to spot these foundational mathematical errors in your own work before the examiner does. If you are rushing and you drop a factorial in the denominator, you are actively handing your hard-earned method marks right back to the exam board.
The entire philosophy behind why the exam board is so strict about this is because the assessment framework explicitly prioritizes analytical depth over superficial breadth. Look, superficial breadth is just memorizing the formula but having no idea why it actually works. Analytical depth is what the top-scoring candidates demonstrate. It means considering different perspectives, for instance, analytically justifying why an expansion of 1 minus 2x to the power of a half is only valid for the modulus of x being strictly less than a half. And you know that's based on the rules of convergence when you substitute 2x into the standard formula. The examiners have stated in no uncertain terms that to get those final A-star marks, you have to push past the basic descriptive level and plunge right into this deep, evaluative mathematical analysis, definitively proving the boundaries of your expansion.
We are nearing the end of our tape review, folks. Let's recap with your ultimate game day checklist. I want you to take a mental snapshot of this framework right now. Your cognitive domains, that's your knowledge, application, and analysis. They must be satisfied by perfectly deconstructing the question, selecting the proper fractional formula, factoring out constants correctly, and integrating those cross-topic connections like partial fractions. Meanwhile, your procedural requirements demand clear annotation, appropriate mathematical formatting for things like factorials and brackets, and the absolutely correct terminology for convergence bounds. You prove these by explicitly defining your terms, laying out your algebraic steps logically, and keeping your positive and negative signs crystal clear. If your working ticks every single box on this checklist, you are successfully executing a full-mark play against the Cambridge Mathematics 9709 examination. And that is the final whistle for today's film review. You have the playbook, you know all the examiner's algebraic traps, and you know exactly how to execute for maximum points. But look, knowing is only half the battle, right? Consistent, focused, mathematical practice is the rest. So, before you click away to study, I need you to do 3 quick things to stay accountable. First, subscribe to @AceTheExams and hit the notification bell so you never miss a tactical breakdown. Second, I want you to go down into the comments right now and tell me your current tier and your goal grade for the 9709 exam. Putting it in writing makes it real. Commit to your goal publicly and let this awesome community support you as we push towards those top marks.
I'm going to leave you with this final provocative thought. It's one thing to understand this structure while sitting here, watching an explainer in a relaxed environment with your snacks, but my question to you is this. Have you truly built the analytical muscle memory to balance complex fractional exponents, maintain absolutely pristine bracketing, and evaluate your mathematical bounds when that clock is ticking and the exam pressure is totally on? You have the strategy now. It's time to pull out a past paper and prove you can execute the play. Put the reps in, keep your standards high, and I will see you on the field for the next masterclass.